Okay, polar equation form is polar equation of the form is R equals ED 1 plus or minus E cosine theta, and R equals ED 1 plus or minus E sine theta. Okay, and this is this is horizontal direction. Cosine is horizontal way. Sine theta is vertical direction, and if R equals 1 is a parabola, you know that. And if R is, because E equals what? E equals C over A. So if E is bigger than 1, if R is less than 1, so R equals 1 parabola, R is less than 1 is ellipse. Because what? Because A squared equals B squared plus C squared. Well, C over A must be less than 1. That's for sure. Not R. My bad. E. Wait, R. And E is positive. Sorry, E is bigger than 1. It's going to be a hyperbola. That's what we learned in the previous class. Hyperbola, because in the hyperbola you have C squared equals A squared plus B squared. Well, E equals C over A must be bigger than 1. Okay. So we're going to look at more examples. In the previous class, we sketched the pictures. And next one, we're going to sketch the graph for, we sketched the graph for which one? We did the R equals 15 over 3 minus 2 cosine theta, right? So we're going to do, next one. Okay, sketch the graph. Example. R equals 1 minus cosine theta. Okay, so if you compare with this one, compare with the R equals, we're going to compare with R equals E D 1 plus or minus E cosine theta. So now, since this is 1, this is 1, we don't have to change the something's wrong with that. Okay. So ED 1 minus cosine, we got this is 1, this is 1. Then we have, we just compare this E here, A is minus, so E equals 1. Okay. If this is 1, this is 1, we don't have to change anything, we don't divide it. If it's not a 1, we have to divide both the top and the bottom by a number, make sure it's 1. Okay, then if it is 1, then we don't have to change it. We just look at the number in front of cosine. In front of cosine is 1, so we got this one. So it is a parabola. Okay. Now if it is a parabola, then when we check the D, and we got E equals 1, and then ED equals 1, so the distance D equals 1. And then we look at the picture, we graph it. If it's 1 minus cosine theta, okay, if it's 1 minus cosine theta, so we're going to see the picture is going to be like this. Open to the right. Okay. Because you can look at this R, 1 minus cosine theta. If it's 1 minus cosine theta, then cosine theta is less than 1. Okay, this is positive. R is also positive. And then you have this directrix equals 1 equals negative 1. So you got this distance. The distance from here to here is negative 1. And then this is 1, 0. And then you got x equals negative d equals negative 1. So directrix x equals negative 1. Then you got a y squared equals 4x. Okay. So let's continue more examples. More example. Here first, r equals 6, 2 plus cosine theta. Okay. So I would like you to try this one by yourself for 2 minutes. So what do you got? First, what is the E and what picture, what graph this is. And then find out the vertex and graph it. Okay, so I think if you are done, you should be done right now. So now, what is my first step? Can anyone tell me? Divide both the top and the bottom by 2 because my equation is e d1 plus or minus e cosine theta, or minus e sine theta. So now if it's not 2, so I need to divide the top and the bottom by 2 because this is not 1. You see, this is 1. This is the standard equation. You have this is the 1. It's not 1, so I divide everything by 2. So r equals, okay, solution. R equals 6 divided by 2, 2 divided by 2 plus cosine theta and divided by 2. So if I divide everything by 2, 6 divided by 2 is 3. 2 divided by 2 is 1 plus, and it's going to be half of cosine theta. So now you should be able to tell me what is E. Can anyone tell me what is E? 1 over 2. Very good. So now we compare E with 1. E is less than 1. So this graph is going to be a ellipse. Very good. Thank you very much, Lacey. So got this one is an ellipse. And if this is an ellipse and E equals 1/2, now I can tell I need to find out what the vertex is. Right, the vertex. So we check the vertex. Theta equals 0. Theta equals 0. Then cosine theta will be the maximum value. So I need to find out R maximum. and R minimum. Right? The R maximum is going to be the one of the vertex point. So R maximum, you got when. So first we look at the R minimum. Well, R maximum is either one. So when theta equals 0, you got R equals 6 over 2 plus cosine 0, which is 6 over 2 plus 1. Because cosine is maximum, then you got this is going to be the 6 over 3 is going to be 2. R equals 2 is 2, 0. Okay. And then we check the other side. The R maximum actually is theta equals pi. Theta equals pi. And R equals 6, 2 plus cosine pi. Cosine pi is going to be negative 1 is the minimum value for cosine theta for the R is going to be biggest value. So 6 over 2 minus 1 equals 6. So you get the other side is going to be 6 pi. That's not a big problem. You can see 2, 0, 6 pi. If you graph the picture, you graph the point 2, 0. This is 2, 0. Okay. Suppose this is the we don't call it a. It's not a orange point, but it's like orange point. But it's a polar. Start with the polar axis here. Okay, this is 0, 0. So the other one is 6 pi. So you go the other side is 6 pi, because the angle is pi, and you go the radians is 6. Then your center actually is 2, 0. This is 6 pi. The whole thing is 8. Then the graph is going to be like this. Goes to here. Okay. You graph it. It's like this. Does it make sense, everyone? Okay. So next one, we check the next example second. R equals 5, negative 1 plus 2 cosine theta. We can try this one. Okay, so for this one, this is -1, is not +1. So we divided both the top and the bottom by -1. Make sure this is +1. So you got -5, 1, minus 2 cosine theta. Divided both the top and the bottom, everything by -1. So that I compare this with e d1 minus e cosine theta. Well, plus minus is either one. Plus or minus is fine. So now e equals 2. You can see the number. The coefficient, the positive negative is just the positive axis, while negative axis. So it's the direction. So it's just which quadrant? Okay, left side or right side. But is this number matters. E equals 2 is bigger than 1. So obviously this is going to be a hyperbola. Okay, if it is hyperbola, then we're going to check when theta equals 0. Because theta equals 0, cosine goes to maximum. Theta equals pi, cosine goes to minimum. So that gives you a vertex. Theta equals 0, r equals -5 of 1 minus 2 times cosine 0, which is -5 over 1 minus 2 times 1, which is -1 over -1, which is 5. So the first point you got is 5, 0. You can graph the 5, 0, right? The next one, theta equals pi. We check it. So r equals -5, 1 minus 2 cosine pi. Now this is going to be -5 of 1 minus -2. Sorry. 2 times -1. Which is -5 over 1 plus 2 is 3. Which is -5 over 3. Well, then your point is -5 over 3 pi. Okay. There's a problem here. When we draw the polar coordinates, I'm not sure if you remember that. You always have a polar coordinates 1, for example 1, 0, for example 2 pi over 4 with you got what 5. Okay, pi over 4 pi over like you have a lot of points, but all of them, for example this one, you got 2, 3 pi over 4. You can tell me r is always what? R is always positive. I always have r is positive and another angle. So now I got r which is negative and an angle. So what am I going to do here? I have a question here. Can anyone tell me what do you think I need to do here? You're going the opposite direction. Very good. Okay, thank you very much. Since this is negative, what you can do, you can change this into positive. Well, when you change this into positive, for example, I do 5 over 3. I change the negative 5 over 3 into positive 5 over 3. That's what I need. I cannot say, oh, I just changed negative into positive. That's not okay. You change this one from negative to positive, then you have to do something on the angle. How do I do with the angle? Since you shift this one, change the side. You change the side. For example, the point is here. You change the point to here. You change the negative into positive. You switch the side. You do the opposite side. Then, what you need to do, you have to do something on the angle. And to reverse it back. How do I do that? You can add pi or subtract pi. Okay? So, you can subtract pi or add pi, either one, because it doesn't matter. If you add pi, you go in this way. If you subtract pi, you go, sorry. If it's from this, if it is this point, it goes to here. If you add pi, it goes back to this one again. If you subtract pi, it goes back to here. If you add pi, actually it's a negative, right? So, if you add pi or subtract pi, it goes back to original point again. You just kind of like pull it back. Okay, so here you can have 5 pi over 3, 2 pi. You add pi on this. Change this negative into positive. Add pi on the angle. Or 5 over 3, you subtract pi from the angle. These 2 points are the same because 2 pi and 0 are the same angle. 2 pi is equal 0, right? Since it goes a circle. If it's 0 here, if it's a point here is 0, it goes 2 pi, you go a circumference angle, you go back to this one again. Because 2 pi is a circumference angle here, right? 360 go back to itself again. So either one of this is fine because they're the same thing. 0 and 2 pi is the same angle, right? The circumference. It goes to another circle. So you go back to your original point again. So whenever you change the negative r into positive r, your plus pi will subtract pi, and it goes back to the original point again. That makes sense, okay? So why do I do this? Because I need to use the point. I need to graph it. 5 over 3, 0, I can graph it. 5, 0, I can graph it, but not negative 5 over 3. I can change it to positive r, and I can graph it. So now, then the picture is going to be 5, 0 is here. 5 over 3, 0 is here. Approximately, okay? And then this is a vertex. You graph it. It's like this. Okay? You can do more work based on this picture because you can tell the center is 5 plus 3 halves. It's 5 plus 3 halves. 5 over 3 and divided by 2, which is 25 over 5. Which is 15 over 3 plus 5 over 3 divided by 2, which is 20 over 3 divided by 2, which is 10 over 3. You can do a lot of things here. You can do this is center is 10 over 3, 0. You can find out the A, you can find out C, you can find out the A here, which is 5 minus. You can find this one is 5 over 3. You can do more work based on this. Okay, it depends on what the problem asks you. It asks you sketch a graph, that will be enough. If you ask her what is A, what is C, you can continue more work based on this picture here now, right? You can tell this is a center. The center, this center to this one is 5 over 3, to this one is 5 over 3. And then, is it 5 over 3? 30, no, wait, let me see. 3 over 10, 10 over 3 plus 5 over 3, which is 15 over 3, which is 5. That's right, okay, it's 5 over 3. So you can get A equals 5 over 3. Since C equals what? E equals 2. E equals 2. And E equals C over A. You can get C. You can get C equals E times A equals 2 times 5 over 3, which is 10 over 3. You got C. You got A, right? You got A and C. So you got C equals 10 over 3. You got A, you got a C, you can get a B. You basically got everything. Center, C, A, right? Okay. It depends on what the question asks you. You can do more practice on your homework. Okay. It depends on what it asks you to find. So normally it asks you sketch a graph. Or it asks you C, ask you A, you can do that yourself, do more, okay, explore more parameters. So number 3, one more example. R equals 8, 1 plus 4 cosine theta. I'm going to call a student for this question, okay? so I'm going to ask the student here. Alright, so Taylor, could you please tell me what you got for this one?
Well, the E is going to equal, the equation's already in the form that we need it with 1 there, so E is just going to be 4, which is greater than 1, so we have a hyperbola.
Very good.
And then when checking the minimum and maximum, we can plug 0 in for theta, and that'll give us 8 over 5, because it's 8 over 1 plus 4 times 1, so, and then when plugging in pi, we're going to get negative 8/3. So those coordinates are going to be 8 over 5 and 0, and then since that's a negative, we can change that to a positive and add pi, so 8/3 in pi will be our coordinate.
Okay, this one is negative, is it 8 over 3 or negative 8 over 3?
I got negative 8 over 3, but when we add, we can add pi and change that to a positive 8/3, I think.
Yeah, you can change that in positive by changing the pi into 0 or 2 pi, right?
Oh, yeah.
Yeah, when you change that, the r into negative into positive, you have to add pi on the angle to pull it back to the point before. So change this into negative, you change your angle as well. So kind of a negative goes give you positive. The same idea kind of, okay? So we got this, everything is right. You got this point, so if you graph it, and you got 8 over 5, 0. Another one is going to be 8 over 3, 0. And the graph is like this. Okay. So this is 1 plus 4 cosine theta. Well, sometimes if it's sine theta, if this is sine theta, you would go, if it's sine theta, you would choose theta equals pi over 2, or theta equals 3 pi over 2. You're going to get it this way, okay? If it's sine theta, you go pi over 2 and then 3 pi over 2, sine 3 pi over 2. So, but it's same idea, exactly same way to do this, okay? So, next one, we're going to see the Kepler's law. Which if you learn physics in future, we're going to learn this again, I think. So first is each planet moves in a elliptical orbit. Orbit with the sun as a focus point. Is a focus. And second, a ray from the sun to the planet sweeps out equal areas of the ellipse in equal times. Number 3, the square of the period is proportional to the cube of the mean distance between the planet and the sun. Square of the period is proportional to the cube of the mean distance between the planet and the sun. I think if you if you study physics, you learn physics in the future, you are going to review this again, and the sun. Okay, so basically this using a we're going to use the polar equation to do some application on the based on the the planet. Okay, astronomy, physics. Next one, we can look at an example. It's pretty similar like what we did here. Actually, it's pretty similar like the ellipse example. It's very much like an ellipse example, but it's basically it gives you the condition or numbers on the word problems. That's the only difference. Okay, so for example, on November 27, 1963, the U.S. launched a Explorer '18. Okay, its low and high point above the surface of Earth or approximately 119 miles. 119 miles, which is not really far away, right? 100 miles is not that far. And 123,000 miles. The center of the Earth is the focus of the orbit. Find the polar equation. For the orbit, and find the distance between the surface. Okay. Of the Earth and a satellite when theta equals 60 degrees. So basically give you a word problem. A lot of the numbers previously we give you numbers, vertex. Now kind of give you a word problems, ask you to find the polar equation. And the radius of the Earth is, does anyone know the radius of the Earth? 4,000 miles. Okay. And then solution. If we draw a picture, see the Earth is in one of the focus point, is right here, is on the focus point, right? And then and here I probably have to draw the Earth a little bit bigger because the Earth has 4,000 miles as a radius, but this distance is here, is right here, is 100. This is 4,000. And then the focus point is here, and then this is the highest point, this is the lowest point. Lowest point is 119. The highest point is 123,000 miles. Okay, so we're going to draw the picture like this. Okay, so this is the satellite. It goes around this elliptic orbit. It's not like our ellipses. Just consider this is ellipse. Okay, so now we'll look at the vertices. What is the vertices? Okay, so first, we look at the vertices. Vertices is the highest point is 123,000. Starting from this center, this is a focus point. Okay, so vertices is here. The vertices of one of them is going to be 123,000 plus 4,000, and the angle is 0. Because from here to here is 123. This is 123,000, and this is 4,000, which is the radius of the Earth. Okay, and also the other one is going, the left side is pi. This side is 0. This side is pi. So the other side is going to be 119 plus 4,000 and the pi. You have two vertices. Now you got the first one, it's going to be 127,000 and a pi. Sorry, 0. The other one is going to be 4,119 and a pi. Okay, and then the whole distance. This is the ellipse, and then the whole distance is what? Is 2a, right? When you graph an ellipse, if you have an ellipse, you graph this from left side to left point to right point. The whole distance is 2a. This is the a. This is the a, right? So we can do 2a. Okay. What is 2a? 2a is. Can anyone tell me what is 2a? This is 119. This is 4,000. This is 4,000. This is 123,000. So the 2a equals 119 plus 8,000 for the diameter of the Earth, then plus 123,000. Okay. So 2a equals 6. No. You add everything together and divide everything by 2, you got a equals 65,559.5. Okay, that's your a. Okay, so what is c? What is c? So suppose this is the center. Suppose this is the center. Okay, this is the center. Then this is the a. You got a is 65,559.5. Now this is the a, and I would like to know what is the c here. This is 0, 0. Suppose this is center here. So I like to know the c here. So what is this distance? Right, the c. So a equals this. C equals a minus 65,559.5. C minus C. The whole thing is a. Sorry, is a. C equals a minus 4,000 minus 119. This is C minus this one, minus the blue one, right? The whole thing is 65,000. And then the blue one, subtract the blue one, is going to be the green one. The green one is C, right? This is C. And this is the A, right? So now you got a C equals 65, subtract the 490. So you subtract the 4,000, subtract the 119. So C equals 61,440.5, 61,440.5. So now you can find the E. E equals C over A. So equals 61,440.5, 559.5. So you got E equals 0.93717. And then the function is R equals ED 1 minus E cosine theta. Right? So I got E. The next is I'm going to find a D. I'll stop here. And we're going to see tomorrow and finish this whole question tomorrow. And you go back and review the whole question again. And finish your... We don't have homework for this week. But you do your final exam practice for this week. And before the next final exam. So you have the whole weekend, about 10 days to finish that practice final exam. Okay? Thank you very much. I'll see you tomorrow.